for the transition to the replacement for Hangouts is abandoning all of their Hangout support.
Yeah.
That's really what's happening.
So we could
So
discuss
it's
this
possible
kind of.
that in a few years, once all the free stuff gets moved over to whatever their new service is going to be, YouTube will support that properly. Who knows? All I know is that next month, YouTube drops all of their actual support for Hangouts.
Yeah. So we could discuss this later. We're gonna just get started here.
Yeah, where is everybody?
I don't know. I think Wilfredo and Michael Gargano will be joining us shortly. There are a couple of
I should
topics.
post something in news.
Yeah. So the topic today, as you guys both know, is efficiency. There's quite a bit of interesting things. Like,
oh yay, more type checking.
oh yeah, we're not doing more type checking. It's just that Chapter 7 goes through some interesting things. Particularly, he introduces us the importance of using the disassembler. We talked about that last week a little bit. I want to discuss a couple of the code examples that he had in there. Specifically the reader macros, because we've touched base on reader macros in detail and in depth. But in terms of efficiency, Hoyt seems to be of the opinion that to compress meaning, you want to use a reader macro, and a lot of folks tend to not like reader macros. And reader macros tend to mess up a lot of different aspects of using Lisp. I mean, we saw that when we were doing a couple of previous streams. So I wanted to see what your guys' thoughts are on the reader macro
one thing
he created.
Touch on is reader macro. Writing a reader macro alters the standard read table.
Right.
And there wasn't the named read tables library when that book was written, which solves it, although in a inconvenient way.
Could you describe that library a little bit? Just so that, because I've never used the named read tables library. So,
well, it basically allows you to namespace the read table per file.
Per file. Okay, it's not per package. All right. I thought I was under the impression when I heard that.
No, it's per file, and it requires a form to be placed at the top of every file. Okay. That's the inconvenient bit about it. Technically, you could hook it into ASDF to do that automatically, although, I mean, still, it's sort of a hack in my opinion.
Yeah, and that has other issues, like, that means that you can no longer load the file using, compile and load file in Slime.
Oh,
right?
Really?
Because if ASDIF is setting up the read table around its load of the file, then you're not setting that up if you load it separately.
But anyway, if you're not using named read tables, there's just a global read table, right? And if somebody defines the same reader macro in multiple packages, which is, a possible case with, a huge ecosystem like CL with ClickLisp. Well, not huge, but large.
Large enough.
Large enough. That could cause major issues when, not even... more than package issues, which those are already plentiful. When you quick load something that could just fail if there's a conflict.
Interesting.
Yep. So named read tables, set your read table per file if you really want to do that, And there are other problems with using read tables for things.
Just give me 1 minute. Someone, for some reason, is knocking at my door. I apologize.
It's always the same time.
We're having a slow start today anyway. I don't think it's that big a deal.
Here. Who cares?
I mean, we are recording it, so, people watching later will be irritated we wasted this much time, but, they can skip through it.
It's a free service.
Yeah. And unlike the people watching live, they can scrub.
Yep.
Ideally, we'd have timestamps, but that's not something we have nearly enough time for.
Yeah.
Well, I posted the link in the news channel on the Discord, but but it does not appear to have garnered any interest. Apparently, people are busy right now.
Yep.
Okay, my apologies. It's my
You're fine.
delivery guys. For some reason,
we kept the stream interesting while you were gone.
All right. So yeah, like I understand the use for name read tables and just using reader macros in general. But I was wondering, like, in terms of the at least the topic of the chapter in the specific case where he was using reader macros is to you create the declare expression that's needed to encapsulate or wrap around a particular block of code that you want to either optimize for complete speed efficiency or make it safety or try to do some in between there. So if you look at this example here in my Emacs buffer, this is the reader macro that he generated. Now all this does is it checks to see if numarg is less than or equal to 3, and then make sure that the appropriate speed and safety flags are set up accordingly. So like in this example here, I'm not sure if, hopefully you could tell me if you could read my mini buffer here, but when I expand this out, you'll see that it just sets the flag to the speed flag accordingly to like the maximum version if nothing was defined. Same thing here. If you just say 2 instead of less than 3, what this dude here goes and sets up is it says speed is 2 because you specified the numarg argument inside the reader macro, and then it sets up whatever the remaining thing is to 1 or accordingly. Now this brings up one question that I had, because I've seen some folks do 2 1 3 0 0 3 and so forth, and I don't know if we talked about this in past streams, but I wanted to bring it up here, and that is, do you need to actually define speed or speed and safety in the same declare expression if you do, say, I'll try to write this in hard coded. Let's say that you create a declare, you created some dumb function here, and it takes some arguments. In the declare expression, could I just say optimize speed 2, and can I just safely assume that
that won't affect the safety declaration?
It won't affect it at all. Okay.
Correct.
So I'm wondering why he always declares speed and safety at the same time. I guess he's trying to do it for
probably because he wants both of them. He wants to adjust both terms. He wants to simultaneously, increase speed and decrease safety, or the other way around.
But if you do speed 3 here, let me just, but you don't specify, what is safety's default? Is it 0?
There is no known default safety.
Dependent.
Okay, it's implementation.
It all depends on the implementation. I can tell you right now that CCL is different than SBCL.
Yep. The only thing that's required is that if you explicitly request safety 3, you're in what's called safe code, and that can actually change some of the semantics of functions.
I realized with CCL having a different, a more stricter safety value.
Yes. Basically, there are functions which will throw errors in certain cases where they would otherwise silently accept that you're doing something stupid. In safety 3, it requires that the error must be thrown, whereas the other levels of safety will just are allowed to silently pass the error along. I think that the terminology in the spec is sort of like, it's something like an error will be thrown versus an error must be thrown, or something like that. And an error must be thrown is in all safety levels. It's documented at the start. Let me look it up.
Yeah, should be.
In the anti-standard, in the CLHS, because I have
in the CL hyperspec.
Okay.
Yeah, it's in 142.
Okay.
Yeah. Yeah, it's one of those like introductory, we're setting up our definitions, sections.
An error is signaled, or an error should be signaled, or should be prepared to signal.
Right, yeah. An error is signaled is both safe and unsafe. An error should be signaled it is only required to be signaled in safe code, and should be prepared to signal means that it might signal, but there are no actual guarantees on whether or not it will signal.
So this is in 142, you said?
Yep.
Okay.
Error terminology, safe code, errors, consequences, etc.
Ah, okay. So I have to. So this is kind of important that that to understand that it is implementation defined. So to really have like cross Lisp code that kind of encounters some of the has many cases as wanted, so we could use our Lisp library in multiple places. We would want to probably reference this guide to find the must cases and account for them accordingly, right? So that
Yeah. So an error is signaled in the spec means that there will always be an error signal in this case, right?
Okay.
The example they give for that is an error is signaled if unexport is given a symbol not accessible in the current package. You can't unexport a symbol that's not in the current package, so an error is signaled. An error should be signaled is plus should signal an error of type error if any argument is not of type number. So if you give something that isn't a number to plus, it should signal an error. It's not actually guaranteed to signal an error. It's only guaranteed in safe code, meaning code where you've explicitly requested safety 3.
Okay. So so the way he handled some of this stuff is he created these reader macros, and particularly he uses the reader macros in a regular macro to generate what he calls like prog end blocks that are of a specific safety level. And so what you could do is
silly to me.
and I don't understand if this actually this is something that I was going to ask because I haven't encountered this in places. He says that you could actually then add safety checks, like predefined checks, like checking boundaries for a vector and so forth, before actually running your fast code. Like you can actually then optimize, knowing that the safety checks have already been done, and the compiler will end up being able to generate fairly efficient code because what you've done is you've done all your precondition checks before actually optimizing your code later on. Does that actually work, or is that actually
It depends on the compiler and the situation.
Got it. All right.
There are cases on SBCL where it is definitely clever enough to tell that it doesn't need to do a check again because you've already done one. There are also a lot of cases where it's really not that clever.
So even if you wrote it this way, like if you follow this as a pattern, there's not necessarily a guarantee given the compiler that you're using. Okay.
No, not at all.
Okay.
Optimizations are always tricky.
Yes, and I understand that, and that's why I bring it up because he seems the way the book is written.
It's a good paradigm to follow in a lot of cases, but like everything, profile when you optimize.
Yes, and that brings up a topic that we must discuss eventually. Like I'm thinking about next week because this is something that I want to bring up to you two, and that is I don't know. I see a lot of notes on Slime's hooks into the profiler, but I didn't see anything related to the updates Sylvester did to the. They use the same.
Sly has. I believe it does not have the deterministic profiler contrib.
It just has this. Does it have the statistical one? I forget.
I could be mixing those two up, but it only has one of them.
Okay.
Yeah.
Unlike Sly, which has both.
Slime, which has both.
Yeah.
So Slime.
So Slime has both the deterministic profiler hooks and the statistical profiler hooks for. I'm assuming
Sly
you mean
only has
SBCL.
one of them. Yeah, SBCL. The deterministic and statistical profilers are specifically SBCL things.
Yes. When you leverage the profiler across other Lisps, I guess it really you need to go and look into.
Well, there is no portable profiler.
All right. There's no portable.
The profiler is specifically a feature of whatever Lisp you're using, if it has a profile or not.
Yeah, there's no functionality in the standard that mentions profiling.
Okay.
Yeah, the closest thing to that is time.
The closest thing is time. All right. which really is.
Time, the poor man's profiling.
or I guess in a way, room.
Mm.
Wait, what?
Yeah, time and room.
Room? I've never.
Room.
Yes.
It's a function. Call it. See what happens.
You might want to pass the argument, though. I forget what it's called.
It's not necessary.
So you just say room, like this?
It's a function. You call it.
ROOM, as in.
Yep, that's the one. You had it right the first time.
All right. I'm not getting any. Okay. Optional.
I think it's all, but I forget.
Is the
like colon all.
Okay.
No, that's not it. Let me look.
Yeah, maybe going mad.
Oh, well, okay. Let me just not specify anything. Wow. Okay.
Mm-hmm.
Dynamic space usage, immobile space use.
Oh, yeah. You just pass T as an argument.
Oh yeah.
Hold on. What is
room T?
Does this give me anything? Let's see. Prints a standard out information about the state of the internal storage and its management. If it is T, room prints out a maximal amount of information. Default.
Yep.
Okay.
Room T.
Room T. Oh wow. Okay. And this gives us quite a bit of information.
So it gives the information about like which types of objects are alive and haven't been garbage collected, and information about the memory in your image.
Yep, and what percentage of that stuff is in mobile versus immobile versus static space?
Could we?
Which, by the way, C-Lisp actually has quite a detailed report here. I was able to track down a memory leak in my game engine that SBCL had no idea about on CCL.
By using room?
So different implementations are free to provide whatever information they want in room.
Okay.
I don't believe there's any requirements in the standard. I'd have to go double check on that though.
Yeah, I don't think there are.
What's the difference between immobile space and static space? I would think
that's an SBCL question.
Oh, all right. That's an SBCL question, so it's not necessarily the same. All right.
No.
Good to know. I did not realize that. Okay.
The mobile versus static, if I remember correctly, static space is the one you get when you run Purify, I think. Don't call it. Firstly, it's not in CL user.
Okay, just wanted to make sure. I was just like, what? I never heard of Purify.
It's an SBCL function.
Okay.
It takes everything that's currently in your image and marks it as don't even bother checking to see if you need to GC this.
Okay.
It doesn't disable the garbage collector. It just disables it for all of the memory that's currently in use.
All right. Oh.
And the usage for that is right before you dump out an image of your application for final deployment, a common step is do a full garbage collection and then purify all memory. Basically say that everything that's still in the image at this point, mark it as never bother trying to GC this bit of memory again. Assume that everything that's live now is always going to be live in the future.
Oh, so that's one way to make a deployed application. I always thought...
It's one of the options when you deploy an application on SBCL. Okay. SBX save Lisp and die has a purify option that runs the purify function before it exports the application.
Gotcha. I always do through ASDIF, I think it was deploy op or something like that, which ends up loading... before, and I run it in a script, so it loads up the list of image, then loads up all my libraries, and then does a dump.
Mm-hmm.
Okay. That's...
Yeah, no, deploy op's not a bad way of doing that. Like, it's not the one that I tend to use, just because I usually know that I'm targeting SBCL, and I know what other options I want to pass to it. But deploy op is definitely a good sort of semi-portable option for generating a deployed executable.
We really ought to do a stream on that, on deployment.
Yeah.
Because there's more involved than just, the SBCL or whatever implementation's internal function that's die. I mean, especially when dealing with foreign libraries.
And bundling.
And especially when you start leveraging, like, external
and reproducible builds.
C++ libraries, it becomes very, very useful, or system libraries, it becomes very useful because you need to, in your deployed application, keep those DLLs in a way so that when the application builds,
Well, yeah,
they're
you
available.
actually have to unload all the foreign code before you dump, and then have a hook that's loaded, that's called when you start the image or start the application, that reloads them based on the paths that they're in on the user's machine. Because
Right.
the paths may differ between your machine and other people's machines, and you don't want
Yep.
those paths hard coded into your image because
Right.
then you won't be able to find them.
Exactly.
There is an automatic process which automatically unloads and reloads shared objects on most image deployments on most Lisps. It's usually really dumb about its path handling. And so it works for you, but not when you carry that file to a different machine and hope it works there.
I mean, there's certain ways of doing that, at least depending upon the operating system that you leverage, so that it localizes those.
No,
things, right?
not necessarily. Quite a lot of Lisps, their default shared object file reloading process hard codes the path that it found for the library previously.
Oh, okay. That's
Yeah.
not good. Yeah, we need to do a talk on this because that's
And so the way you deal with that is you explicitly unload, and then, as Michael said, you have a hook that runs when your code starts back up again that reloads it. And there are a variety of different ways of automating that process, and it's admittedly not something that I've looked into extremely in depth. I'm sure actually Michael knows more than I do in this particular area.
Yeah.
Borodas actually has an article on his blog.
Yeah, Borodas probably would know the most about it of all of us.
Yeah, that dude just, wow.
He loves his native libraries.
He's a machine, and that's all he does is see
wrap native libraries,
wrapping it up with Lisp.
Yeah, I mean, I'm slowly starting to get into that. I've just started looking more into CFFI. I'm trying to come up with a good example of like some networking stuff that I used to do in the past, like using 0MQ. And I'm not. I know CLZMQ is out there, but I don't know how up to date it is with the newer versions. So one of the things that I
If
wanted
it's
to do,
CL, just consider it to be not up to date.
Yeah.
Generally speaking, yes, that's a fair bit.
So, and
It's
also
as up to date as you want to make it.
Yeah, and also given the fact that 0MQ changed some of their socket types, it becomes kind of useful
fun.
Anyway, they added
so
additional stuff. Anyway,
we were discussing Chapter 7.
So yeah, we got a little sidetracked there. But so when should we use some of these things? The book mentioned a couple of things, which is about how. And this started getting a little preachy, but about Lisp being an open interface to controlling the compiler. The way you can ultimately start talking about efficiency, you got to first start, dealing with two important things before you talk about the third part. So we need to first ask ourselves, what makes a program slow in general? All of us know this. Bad algorithms will give you very slow code. Bad use of data structures that aren't handling locality correctly for data access, that'll give you also slow code. Assuming that you pick the right algorithms and right data structures for your particular use case and program, then the third thing that brings up is, general code, which is, I don't know what the best way to actually describe this. The closest thing that I could think of is since you're not leveraging, specific implementations based on types. You're trying to generalize as much as you can, regardless of the type that's being passed in. Lisp ends up trying to give you, the most flexible version of what your code could be when it's compiled. So this was why if you noticed, if we did a simple, add function here, going back to something that we did here before in the past, if we went and disassembled this guy, and this is why folks who are just joining us, knowing how to disassemble something is very, very important, and you need to learn how to do that, especially as you start optimizing code. Not only profiling is a different discussion, but in general, you can actually get pretty far too with disassembly too. Notice in line. This line right here. since we didn't specify any type information, we have encountered this and discussed this in the past. We'll end up getting these generic operations instilled in there. There's a lot of logic in these generic function calls that looks at the type information internally at runtime and makes sure it doesn't do certain invalid operations, and in the case of numerical operations, if you do any sort of fixed point arithmetic, if it overflows or underflows, your Lisp implementation will go ahead and promote the type to a much larger type to handle the larger range of numerical operations in order to save you from getting a massive invalid answer.
Which might not even be a number.
Yeah, exactly.
Could be an object.
And that's something to be aware of. If you know what you're going to use, you may want to end up, trying to restrict some of the types if and when appropriate. Don't do it all the time. That also could have its own problems in slowing down your code. But when you profile and you find certain bottlenecks, adding some of that type of information and using what we introduced last week, or no, not last week, a couple of weeks ago, the DAW operation, the DAW form, and locally, you can use a combination of those to actually go and make sure that your code generates something fairly efficient. So one thing that this fast progn and save progn stuff that we were talking about earlier becomes useful for, and more importantly, the third type of macro, which we haven't discussed yet, is compiler macros, is dealing with function invocation. So let me talk about the compiler macro first. So what is a compiler macro? So we talked about reader macros and regular macros and before I introduced you folks to what I would consider to be the Lisp compiler framework, right? And there are hooks into the pipeline where you can customize how Lisp does its thing. So if you think about before the string is read into Lisp in terms of its read stage, you can actually customize how it's parsed and read through reader macros. Regular macros is kind of in between transformations. You could go from one Lisp form to another Lisp expression. Compiler macros is this one special thing which basically deals with function invocation. At least I haven't seen from reading the book and other sites, I haven't seen it being used in other cases. The idea is instead of letting the Lisp compiler compile your code in a particular way, you're actually stepping in there and saying, whenever you see an invocation of this function, go ahead and use this particular Lisp code that I've created instead, and compile that into the code. Is that kind of the right way of explaining that?
The way I like describing it is that it gives you control over inlining.
Okay.
In some ways, and actually it holds given the way the spec actually describes inlining. Inlining is kind of like the simple case of compiler macros. When you declare that a function should be inlined, one way of thinking about that is that you've just sort of implicitly defined a compiler macro which just always generates the full body of the function. Right?
Right.
And so anytime you have calls to that function that the compiler can deduce statically, it can use that compiler macro and inline the full body of the function. But instead of inlining the entire function, you might be able to use some static information about what this function is being called with to generate a much more specialized inlining of that function for this particular call site. And that's where defining your own compiler macro gets useful.
Yes, very well said. And not just what arguments it's called with. You can actually utilize Common Lisp the language too, and with the portability portability library to get access to the environment, such as what declarations are in the body of that function
And
when
what
it's called.
symbols and a full environment in Common Lisp language too includes everything, right? Like what's been parsed, all the symbol tables, etc. Isn't it?
Well,
Right.
it has the variable declaration information and the function declaration information for the
Right.
local environment,
Right.
and a
Uh,
few other things.
so
Um, the environment object isn't something magical like from CLTL2. By the way, it's actually passed into every macro and is required by the standard. The only thing that CLTL2 did was require certain information not only be in the environment but be actually accessible according to a standard API. That's all CLTL2 does. The environment information is there. It's required. Well, what information is there isn't exactly required by the spec, but the object is required to be there anyway by the spec. So, like when you define a macro, you can have your positional arguments, you can have your key arguments, you can have your body argument, and then you can also say and environment and get an environment object,
Along
right?
a few others like ampersand whole.
Right, which gives the entire input form.
right.
And the value of and environment portably is that you can pass that into macro expand, basically. And the reason why you do that is that's how you make sure that macro expand will expand any local macros. So if your macro is being used in the body of a macrolet,
Yeah.
right,
Mm-hmm.
and your macro needs to do a macro expansion, you want to ensure that you aren't just macro expanding global macros, you're also macro expanding any local macros that are defined around the call to your macro. And so the way that you ensure that happens is you capture the local compile time environment as an argument to your macro, and then you pass that into your call to things like macro expand or macro expand one, or actually there are a wide variety of other ones. There's also like get setf expansion also takes an environment because you can locally define setf expanders, and then a few other things like that. And so the environment object is required to be there by the spec, but for all intents and purposes, by the spec, it's this opaque thing that you just kind of have to pass around if you want to ensure that certain other APIs respect local definitions.
Yeah, but that while it is required by the spec, it's not necessarily something that is exposed, right? I mean,
Well,
unless you use CLT.
Depends what you mean by exposed, right?
Okay.
Because the object is there, you can capture it, you can store it in a variable, although that's not recommended, and I think it's technically allowed to be dynamic extent. But the object is there; it's a thing. You can pass it around. You can stringify it and print it out. You could, if really you wanted to, although I do not ever recommend doing this, you could insert a breakpoint into your macro expansion, into your macro definition, and drop into the inspector and actually just look at the environment object. Whether or not that would always actually work portably is up for grabs. But, I mean, it is an object, it's a thing, you have it, you're passing it around. So it's not, it's exposed in the sense that you have it, but there are no APIs, there are no portable APIs for introspecting on the environment object apart from calling other functions with the environment object to make sure that those functions respect that environment.
Well, there are portability libraries for it.
Right, and that's the thing is that most implementations implement the API provided by CLTL2, and there are portability libraries that let you use that. But all of those are functions that let you directly introspect that environment object that you already have.
Right. Okay, but so what you're saying is those are portability libraries to extensions in each of the individual Lisp implementations that give you the ability to actually still look at these environment objects as you pass them from one macro to another. Because in these examples, like in these macros so far that we've discussed, all the simple macros, we've never actually encountered this environment object. But you're telling
Correct.
me that it actually does exist. It's just internal to this. So when I talk about,
we've just never needed to call a function in one of our macros that relied on the local environment.
Got it.
So
All
we've
right.
just never used that feature.
So it wasn't necessary for the macros that we've developed, but it is
Correct.
there. Okay.
Yeah.
All right.
We just haven't been so here's little bit of secret truth here, right? Every macro is implemented by a function of two arguments,
Right.
right? Those two arguments are the form being macro expanded
Yeah.
and the local compilation environment.
Yes. Okay. I see.
Every macro is actually implemented as one of these functions of two arguments. And what you write with a def macro and like breaking apart the parts of the form, right? That's the destructuring bind that's being done on that form.
But when you macro expand, what happens is it doesn't invoke that function. Well, I guess it does invoke that function with the compilation environment, and then it just injects the.
It just takes whatever that function returns and returns it.
Okay, but it doesn't evaluate it though. It expands because that's where does the source code get expanded? Like if I do a macro expand, let me see if I have a.
So go over to your REPL.
Okay.
Right? Have you compiled that safe prog n macro?
I thought I did. Hold on, but let me just do it just in case. And
yeah, just
okay.
so that I have a macro to give as an example here.
Okay.
Call the function macro function, macro dash function.
Oh, macro dash function. Okay, got it.
Mm-hmm.
Macro dash function. All right.
And pass in the symbol safe prog n.
Okay. Safe.
Either one, really, but
okay.
There you go. So that function, it's a function of two arguments.
Right.
It's a macro function, but it's a function of two arguments, and those two arguments are a form that should start with the symbol safe prog n, and the compilation environment, which you're allowed to pass in as nil. So you can now call that function using funcall. So like funcall star, and then give an invocation of safe prog n. So quote, open paren, safe prog n, and then
let's do like 1 + 2 or some idiotic thing.
Sure.
Okay.
And then pass nil as the second argument to the funcall.
Okay.
Not there. That's inside the safe prog n body.
Wrong one.
Sorry. One more paren out.
Yeah. There we go.
Yeah. Nil is the nil works as the empty lexical environment.
Right. Oh wow. Okay.
Yeah.
So it did not actually. I see. It took the string. Now it took the actual safe prog n expression, and then
not a string. It's a list.
It is a list. Oh, okay. Sorry.
Yes.
It passes in the list for that form, and then it's the form in list form, and then the nil environment, and then it just invokes that function call that you just shown us here.
Mm-hmm.
Okay.
In fact, the way that you can implement macro expand 1 yourself. It's actually not even difficult. Macro expand 1 can be written portably in terms of macro function and funcall.
Both of which are part of the standard. Yeah.
Yes.
Got it.
And macro expand can be implemented in terms of macro expand 1. It just repeatedly calls macro expand 1 until there's no longer a macro invocation at the head of the form.
Right. Okay. All right. That makes sense.
And so so this is what actually, in a sense, what's actually going on internally during macro expansion. It traverses your code recursively, and anytime it finds that a form that's like a regular full expression form starts with a macro, it extracts the macro function by that name, and it passes in that form and the current compilation environment. And then it processes whatever that returns.
Yes. Okay. That makes sense. So this follows standard compiler design, in terms of macro expand. So we just keep on going from one source, one stage almost of the expansion until we hit no more macros that need to be expanded, and each call will store that information, I guess, in the compilation environment that we passed in, so that it's it's
Well, I
aware
mean,
of.
so as you process the special forms,
Yeah.
as you step into the sub-expressions of the special operators,
Hmm.
you have to extend the compilation environment to respect the local definitions that
Right.
those special operators introduce.
Right. And that's what I mean by you have to
Yeah.
update the compilation
Yeah.
environment with any new information that was created
Mhm.
as a result of the expansion. Okay.
Well, not necessarily as a result of the expansion, but just as a result of processing the sub-expression of a special operator.
Okay.
Right?
Oh,
Because
okay. Got it.
macro expansion is just a function call. There's no new definitions it introduces.
But if there's a special operator that
Like
introduces,
let, for example. You know, when you process the body of a let, you have to do it in an environment which is extended with the knowledge that there exist whatever variables that let creates.
Right. So the compilation environment will hold nested environments in it if you have multiple lets that are being generated.
Nested environment, perhaps not the right way of describing it. It depends on the implementation.
Okay.
You have no way of telling if it's like a nested structured tree environment or if it's just like a table that gets extended and retracted from or whatever. But the point is that
that's implementation details. Just conceptually, though, it's getting updated based on special operators that create new environments that are as a result of that were generated as a result of the expansion. So if you created multiple lets and you need to expand more, you have to first update the environment with those lets first because you need that information in the next expansion call. Okay.
Correct.
All right.
Same thing with labels or flet or whatever. And this is also true not just of special operators that are generated by macros, but also special operators you write yourself. If there are macro definitions inside the body of a special operator you've written, those macro expansions have to be done in the context of the definitions that the special operator you wrote introduced.
And what's interesting about that is Hoyt actually mentions this kind of thing, but I didn't quite understand it when he was talking about the keyword invocations and how expensive it is. So he went through the process of what happens when you call a function call with keywords, right? Which kind of sounds like the same. Yeah, with keyword arguments, it sounds like it's going to be kind of the same idea because what happens is it parses it, it generates this environment with a list of key value pairs, and then what it will do is it will inject those key value those values wherever the key is actually found inside the Lisp form. So it's almost as if it's expanding it until it gets to the form where there are no more keyword arguments before it actually goes and evaluates it. So in
some sense.
So the example here that he wrote for this, and this actually now makes this code a little bit makes more sense to me. So what I did was in this example, this is from the book. He strips out the keyword arguments this way. This is just a recursive call going through the keyword list. If it finds a keyword list, it'll go ahead and call the kidder on the list to actually go and expand and flatten out the keyword arguments to their appropriate values or their appropriate variables. So when you see something like this, I could just show this. Let me just compile this guy first. Jeez. There we go. You could see if we do keyword strip, and then we pass in an argument A, B, key.
Have to quote that.
Oh, yeah. That's right. C0. You'll see that what it did was it just kept. It first found the two variables that aren't keyword arguments, added them to the list, found out that key is a list, and then went ahead and extracted that the keyword itself, and then put it in the arguments. And he uses this to actually flatten the list of keyword arguments from their values, and in this defun versus with fast keywords. Now, there is a bug in this my expansion. This is my version of what he wrote because of again, he uses that crazy with GenSim framework that he wrote with the def macro bang. I went ahead and expanded it out to the proper with GenSims. Now, what's funny about this is, and I wanted to bring it up to you guys so that maybe there is something that we can there's a mistake here that I may have missed. Um, this macro, okay, notice I compiled the macro, right? I'm
Oh,
using,
I know the issue. I
what
bet
is
I
it?
know the issue.
Um,
No. I may be wrong. I may
okay.
be wrong. I see something that I think might cause a problem.
So when I try to use this, okay, I just compiled this macro first off, okay? I'm using it here with defund fast keywords for the fast keyword test. Now, if I tried to macro expand this guy, okay, and I tried to expand it, notice it says that defund with fast keywords is not a,
Oh, that's not. Yeah. Hit Q.
okay,
Hit Q. Save your buffer. Make sure it's everything saved.
okay.
That just means that your file was loaded before Sly was started.
Ah,
All you have
jeez.
to do is revert the buffer.
Yeah. Space B capital R.
Space B, capital R. Okay, got it.
There you go.
All right. So
If you have unsaved changes when you do that, it will flush them. It'll get rid of them. So that's why you save your file first.
okay. This is what I was looking for.
The issue is that macro step is kind of dumb, and it assumes that you want the Emacs Lisp macro step unless Sly has already been loaded when that file is loaded in.
Oh, jeez. Okay.
And so it gets very confused. And you'll see if you macro expand something that's an Emacs Lisp macro, it will actually macro expand that, and it'll macro expand it using the eLisp macro expander, and it looks really weird. But anyway.
Jeez. Okay, that was like bothering me earlier. I was like, what the heck is going on? Why isn't this not working?
Yeah, it's just one of those little things. It's a bug in MacroStep. Well, it's something MacroStep just doesn't support, rather. It's not clever enough to realize when Sly gets loaded after a file has been created.
So
after a file's been opened.
So this is what I kind of expected it to do. So basically what we did is we created a fast keyword function, okay? We went ahead and created a fast version of it, which is the flat. All it is literally just a flattened version of this guy, of 69. 70 is literally a flattened version of 69. We compiled this guy and then generated a compiler macro to replace the call of fast keyword test with this new fast function. Now what happens is and this is the example that that he created. He created a little keyword benchmark, and folks who aren't familiar, we were talking about profiling before. This is the poor man's way of actually doing some profiling. You write a wall time based, compilation statistics, using the time function. But this will work on
about that.
What?
I would actually use repeat instead of for I from whatever, because that variable binding happens each iteration, and it actually slows things quite a bit if you have a lot of iterations.
Depends on the implementation of loop, but everyone uses MIT loop, so
yes, just use repeat n. It'll actually give more accurate results.
Okay.
You do. Repeat n do.
And do. Oh yeah. That's right. Thank you.
Yeah. You're fine.
Yeah. Okay. yeah. That's okay. Right.
Shorter code too, so why not?
It's a much shorter code. Yeah, I should have thought about that, but when I saw it in the book, I just was like, he's doing this. There must be some.
You don't need I, so you don't need I, and it's slowing things down. So just throw it away.
Yeah. Okay, so if I try running this, you'll see the error that will pop up in just a second when I run this guy, because I'm just going to run it for 1,000 times. It throws up this. Can't find fast fun 0 is undefined, which tells me that in the macro expand, it's actually doing something in what I'm not expecting it to. Like it's invoking something that doesn't exist, that isn't bound, which doesn't make any sense, because if you saw what I showed you earlier, it clearly is bound. I mean,
macro expand define with fast keywords again.
So that's in the global environment. Huh.
And I'm already been switched over to the to my package, so it can't be a package problem. So
Oh, it can't be a package problem because that symbol has no package.
Yeah.
Well, yeah.
But yeah, the idea should be the same. It should actually generate a basically very dumb benchmark. I want to show the folks who haven't seen this kind of design before. My apologies, I couldn't fix the actual bug that's
Comment
in
out
here.
the call to compile.
Okay. Go in here.
In the macro definition. Recompile that. Recompile the other thing.
Do I need to
recompile keywords benchmark?
Oh, I have to recompile that too as well. Okay, right. Okay.
You're redefining a macro. Have to redefine everything that uses it.
Okay, hold on. I'm gonna go do this.
Okay, again. That's weird. Okay. So that's interesting.
Yeah, and this is on SBCL 153. I mean, we actually, thanks to you guys, 154 I know came out, but
yeah, no. This isn't an SBCL version thing. This is all portable code.
Yeah.
That was why I had you comment out the compile. Part of the reason. Macro expand to fun with fast keywords.
So there's something here that I'm missing, but again. Oh wait, maybe body rest.
That is quite odd because it is, using the coded form of that symbol.
Right.
Yeah.
Can you do me a favor and try removing that gens image just using a regular symbol?
Just getting rid of
the fast fun on the first line of the macro.
Okay.
First line.
Oh, got it. Okay.
And then just, replace all.
Come up with some. Yeah.
Comma
come up with some name.
Remove the commas.
Yeah.
That's the simplest way to do it.
Just want to see if that's reproducible like that.
Because that's just weird. Recompile that, recompile the benchmark.
That's it. Okay. So if there was a problem with the way I wrote.
Yeah, no, that's not okay.
Yeah.
I'm not saying that it's okay, but I'm saying that at least it's related to the Jensen. I'm not.
Undo those changes and recompile everything. Recompile that. Recompile that whole thing.
Compile this guy and compile this guy.
Yeah, and then do
Could it be that I didn't quote
almost
the defund?
want to bet
In the defund?
I should. No. You don't quote it there.
Okay. Fund 0 is undefined.
See, that's just bizarre.
So yeah, I was looking at this earlier. I thought I would get time to actually go through it. It's particularly interesting. What this, for folks who haven't seen this, this defund with fast keywords basically creates a compiler macro that just reinvokes, that just invokes the fast function every time it sees fast keywords test. That's the reason why it takes in two arguments. The one argument is the name of the actual function that it's generating, and that's going to be replacing with eventually. And then the remaining arguments. And
is that compiler macro written correctly? Because I feel like there should be a quote around the whole resulting thing.
A quote or a back quote?
Why?
So if I might be at a different level of evaluation here, but I'm thinking that so after
But,
that,
yeah.
So after that macro expands out, right? The define compiler macro in its body is going to have a raw call to that fast fund.
No.
This is what it expands to right now.
Oh no, yeah, you're right.
So it shouldn't have a raw call.
Yeah, no, you're right. I was reading that incorrectly.
Yeah. That's why I was just like,
restart your Lisp.
Got it. Ah, dang it. That's right. Hold on. Restart Lisp. Give me a second. I'm going to have to reload.
Yep. All that stuff.
Alexandria and
Make sure you save your file before you quick load.
Okay. Well, I haven't added this one to ASDIF yet. This is a standalone one, which is why I need to add, manually load, Alexandria and Serapium. Well, I was using Serapium earlier, but I changed it so I don't need it anymore. But technically, it's in the package definition, so I'm gonna have to place that at some point. All right. Do this. Comma CL. Okay, so that's compiled and loaded.
Make sure you save your file before you do comma CL because it's going to load the file on disk, not your buffer.
Well, Emacs is telling me that my file is saved.
Okay. That's all good then.
Yeah. So,
and now run the benchmark.
Okay. Wow. Must have been
Well, you have the compile list commented out there.
Oh. That's right. Dang it. Save the file.
Recompile each thing. No, don't just reload the whole file. Because there's weirdness there.
Hold on, I'm going to restart my Lisp again.
Yeah, I think there's some load order nonsense going on right now.
Yeah.
Among other things.
Okay. Just load up this guy. Okay. And
need to load the...
That's right. I have to load it. This guy. Let's do CL. Okay. MSS. And I should be able to run the benchmarks. Yeah, there is a loader issue, but it's still compiling.
Yeah, so when you recompile each of those separately, something weird happens.
Yeah.
I don't know what it is. It looks like some nonsense involving the gensim counter. It may actually be an SBCL bug, or some interaction with Sly.
What's interesting about this particular thing is the reason I wanted to bring this one up is it does show that the invocation difference. I mean, you can clearly see the slow keys between the fast keys, just keyword stripping. It's significant. Like that's a pretty.
Well, actually, the fast one is taking longer.
0.0022, isn't it? Where it says 033. The fast keys is taking.
Oh, you're right. Yeah, the real time is different. That's weird.
Yeah.
Well, I think you might have, like, whenever I do any sort of benchmarks, I always call a garbage collection right before it to try and get that out of there.
Okay, so out of curiosity, and this is something new that I've never done, how do you force a garbage collection in Lisp?
SBX GST full T.
SBX.
Yes, that's what he said.
GC space keyword full.
Okay, hold on. GC space full T.
T. Yep, that's the one.
Yeah, so usually, like, in anything that I'm benchmarking, I put a call to the GC, like, right before the call to time. So basically, how I would change it is like in yours, in that keywords benchmark, like right after you do the format, but before the call to time, I would do a GC in there.
For
And
each of
same-
them, so you would do it right here.
No, right after the
No,
format.
between the format and the time, in
Yeah.
both cases.
Okay.
Exactly. So there'd be 2 calls with the GC. 2 calls.
Okay.
Uh-oh. You've got extra time.
Yeah. You've got extra time.
Oh yeah, yes. I must have accidentally typed in Y2Y instead of just YY. All right.
But yeah, look at the difference now. You got much less processor cycles.
Let's see if we get the error again.
Yes, we did.
Aha! That is interesting.
That's weird.
So
And, yeah, very strange.
Okay.
Rewrite the whole file. Yeah, comma CL the file. No, don't bother restarting your Lisp. Just comma CL the file.
All right.
Pet theory. Yeah, now try again. Is it error?
No,
Aha!
yeah, it's definitely
Was the file saved?
the
Yes.
file was saved. So
Okay.
just in case,
It's an interaction with
in
slide.
Emacs, right next to it says 2.4K. See that dash line? If it says star, it means the file is modified. Otherwise,
Yeah.
the buffer is not modified. It matches what's
Yep.
on disk.
SpaceMax is nice that way.
Well, even Emacs does
I
the
have
same
a different. Yeah, I have a different indicator for that.
thing. Oh, okay.
Yeah.
Yeah, I don't try to understand everybody's mini buffer.
Yeah, dude.
Yeah.
Mode line, I mean.
You
Yeah.
see, I was going to, at one point, after you guys suggested Doom, I was like, maybe I should look at Doom just to see. But then I was like, I'm used to SpaceMax now. I don't know if I should
Yeah.
change, because I need to work on actually
Depends on
learning
your
the
needs.
language. Yeah.
Anyway, so yeah, that very clearly makes a difference.
Yeah, that does. And it actually, that's a pretty significant boost in performance. Just by
Oh
flattening
yeah,
and
it's
then
not
doing
just keywords that are slow either. I mean, number of arguments slows things down. Optional argument, all the parsing of the lambda list that your function has slows it down.
Hmm. And you can actually even see that. Here's a fun trick. Do hash quote slow keywords test.
Okay. Enter.
Inspect that. Yes.
Oh, inspect it. Okay.
Enter, and then inspect the presentation.
Okay.
Inspect it in Sply.
That's
Enter.
Oh yeah, that's right. There we go.
Inspect the code object. So, everything before the I think everything before the thread binding stack pointer, although no, it's further down than that. If you go down a ways, eventually you'll hit the no arg parsing entry point. That's the start of the main body of code.
No arg.
Keep going.
Yeah,
No arg parsing entry.
Doesn't show up here.
Oh, that's interesting. Oh, because, yeah, I see. Yeah, it's just segment 3.
Segment 3.
It's just not annotated because the thread binding stack pointer. Yeah, segment 3 of 3. Origin, yeah, you down. After the unknown key arg error, after the odd key args error, segment 3.
Ah, okay.
That's the start of the actual body of the code.
So all these instructions before is just parsing the keywords. That's
Yes.
That's
Yes.
interesting. Very.
Yes. And
very
now you get it.
interesting. Yeah.
Ta-da!
Yeah, it's all.
Yeah.
A lot
All of
code.
that is key arg parsing.
Jeez, that's a lot. That's
Key
a
args aren't
lot.
cheap.
Oh man. All right.
I mean, when you think about that, this is like the entirety of all of the instructions required to do that. And note, there aren't any calls in there or anything. It's all primitive assembly code,
Yes.
right? There's no calls to extra stuff elsewhere. There's no, weird extra functions going on, right?
Yeah, and
this is actually the exact full assembly that implements that. it's actually not that crazy given everything that has to happen in order to parse key args.
Right,
But at
but
the
that
same
means there
time-
are some very expensive instructions in here that are taking several cycles that are causing slowdown.
Well,
too,
it's
right?
just a lot of code
Yeah.
compared to the body of the function. Like, you can visually see
Yeah.
that it's a lot of code compared to the body of the function. Now, admitted the body of the function contains calls to generic plus, but still. Like,
Well, these are just as expensive. Well, they're probably a little bit efficient, but I would say that they're going to be just as expensive if they're doing some type checking behind the
they're
scenes.
expensive
right?
in other ways, yeah. Well, so if you look closely, you notice that that whole thing is basically just a really massive loop, and it's got a lot of loopiness going on in there.
Yeah. I noticed that
The
because
arc
especially
parsing,
the
it's
jump not equals, the jump equals to go to the different blocks.
Mhm.
I would have to draw out the
Yeah.
CFG to actually really go through and see what it's doing.
Yep.
But it's fairly I mean, there's a lot of code in here. It's just interesting.
Some of it's fairly obvious what it's doing.
Yeah.
And some of it's not.
Well, I'm not
Like the
I'm not disagreeing.
comparison with raw pointers there.
Mm-hmm.
Oh, look, there's the bit of code that implements what happens if you pass allow other keys T.
Here, this is the code that you need to worry about. Well, no, this is calling allow other keys here.
No,
right?
that's the code that handles what happens if you pass allow other keys T as a key arg.
Oh no, that's compares. Sorry, I'm reading the instruction wrong. I thought I saw a call there. All right.
Yeah.
Wow.
But intuitively, you should be able to just sort of like understand that essentially what it's doing is it's looking at that rest list and then looking at
Right.
like, oh, am I at C, am I at D, am I at allow other keys, and then jumping around as appropriately.
Right. No, I mean, this code is fairly it is straightforward. I just have to. I mean, I see these are just individual blocks that are being generated for each of the individual arguments.
I mean, I'm not even talking about like. I'm not even looking at the actual assembly. I'm just looking at, look at all these labels and the fact that they've got a section for C, a section for D, a section for allow other keys.
Yeah,
so
that's exactly what I'm looking at.
You can just sort of like infer, it's probably, looking at the next argument, seeing what it is, and so on.
It's just looping through each of the arguments in here, and then once it's done, it will just go out to start this actual function call itself.
Yep. The other neat thing that this shows you is that SBCL has special cases for particular exceptions.
Like the unknown key args error and the odd key args and stuff.
Yep.
So that's interesting.
You usually see those at the bottom of the so when it's at the bottom of each segment, you can see
you see the bits of code it uses for errors.
Gotcha.
Yeah.
That's cool.
You can see there that SBCL actually has special cases for particular exceptions.
I mean, to really emphasize and really get really nice code that matches that of what you would normally get from C for particular blocks of code. You would have to really learn how this kind of works and see what play around with adding the types in the appropriate places so that you can shrink this down.
I mean, Steam doesn't do key args.
It doesn't do key args, but what it does do is adding the type information allow you to shrink some of the assembly after all this. You can
maybe because adding the type information, it depends on the safety and optimization levels. Because adding type information can also like force a type check inline in that function if you're compiling on like higher safety.
Got it.
So it's not 100%.
Right.
And it depends on the implementation too.
It also depends on the implementation, right?
And also, whether or not moving a check earlier in your code can, either increase the speed or slow it down.
Yeah, you need to really profile the code to figure out what the bottlenecks are.
And profile on all the implementations you plan to support.
Yes. Which is hopefully all the major ones.
Exactly. Profiling is very important because, especially if you're changing the safety value, because as we mentioned, errors can raise in different situations depending on, some implementations have different defaults for safety, and that changes the semantics of the code.
Right.
But there are those rules of thumb too. So even if you're doing just kind of like general, not horribly optimized code, you can use rules of thumb. Like, if you type check early, generally that's better if you can go into like a kernel of code that already knows what the types are. That's an SPCL and some other implementations that good rule of thumb to apply, I think.
So one question I have here, and this is a good point of discussion at this time because we're bringing up type checking and stuff, and especially since we're talking compiler macros, is Hoyt brings up this notion that one of the advantages of leveraging compiler macros is since you have control of when to invoke, when like you can control how the compiler actually deals with function invocations. It allows you to take like something like say that's existing, and I may have misunderstood what he said, but you could take an existing code base and leverage compiler macros to actually provide a different like code generation pipeline than what you would use if you actually leveraged the native compiler facilities. So you could actually take an existing code base and make it faster if you know how um, the the function invocations like are being handled, and you can actually go in and change what's actually generated behind the scenes. Do you guys think that that's actually a general good practice? Like if you end up dealing with existing code bases, like you notice that it's slow, it's not giving you very efficient code when you do it as
Step
is.
1, check to see if it's good enough to use inline.
Okay.
Step 2, profile everything. Step 3, consider writing a compiler macro.
Yeah, I think what he's saying is that, without modifying the library, you could define a compiler macro in your own package using that package prefix.
I think that'd be generally bad. I don't know. That doesn't sit well with me.
You're breaking abstraction layers when you do that. It's just generally not a good idea. No. Now, on the other hand, you might write a wrapper around an existing library where you re-expose some of its functionality, and then you can use compiler macros on your symbols that call the other library symbols to inline more efficient code. That might be reasonable, but if you're doing that anyway, that that's its own kind of weirdness. But you can definitely do that. If you are the library maintainer and you want to improve the performance of your library without changing too much of the existing code base, yes, adding compiler macros to it can help, but you need to have good evidence that that actually is a bottleneck in your library with the common use cases for your users before you go down that route. And as I said, step 1, see if inlining does the trick. Step 2, profile everything. Then consider writing a compiler macro.
At the very last, it's sort of like a last thing, like, okay, we need to squeeze a little bit more performance out, but I know exactly
you need more control. There's something that your compiler's not catching for you, and you need to take the
right. It's not catching the hint based on inlining in the other facilities. So
inlining can make your code slower, actually, and dramatically so in some
very
cases.
so.
Yeah. Because for one thing, you can blow your instruction cache.
Cache coherency.
Yep. If you inline too much stuff, you can totally screw up your instruction cache, and then you're doing page faults as you step through your instructions, and no one wants that.
Right.
And so inlining can be good enough if you have a bunch of really tight, really simple, small functions, and it really would be not very much more expensive just to inline that than to inline the code for calling the function.
Right.
Then inline that. And even in other cases, there are cases where it really does just make sense to mark this function as inline. And actually, the other thing that I'm thinking is I wouldn't be surprised if you marked a function that takes key args as inline, if SPCL is clever enough to basically do the exact optimization that you're doing here by hand. On the other hand, inline has its own downsides. Inline has basically the same downsides that defining compiler macro does,
don't
which
be
is screws with
don't be a
redefining.
victim of premature optimization. I mean, if you're inlining functions that are inlined, etc., you have to go ahead and recompile all those.
Right, and you
Yeah.
really want to start
Just like
with then
those.
creating your profile, starting with the profile first at the very least before you start any sort of performance analysis. Figure out what your bottlenecks are, and then go through
Yeah,
it on a
usually you
case by
do
case
that when
basis.
you've written everything works.
Yeah,
You've already
exactly.
written it.
You want, and
Not while you're developing.
right.
Yeah,
Absolutely.
the only exception that I think anybody has any chance of defending is a math library.
Yes.
Maybe.
And even there, you have some.
Even then, once again, it depends on how expensive that function's instructions are, because you could blow up the instruction cache. It may actually be faster to make a call to that function so that that function only exists at one place in the instruction cache,
right,
than it is to inline that function all over your code base.
Right.
In the case of my math library, most of the functions are inlined because profiling, proved that was useful. But some of them aren't because they're much faster not inlined, even though they look like they should be faster inlined.
Right.
Basically, what it comes down to is test everything and optimize later.
And maybe, depending on what the problem domain is, you might never want to optimize just because it gives you that flexibility of, for example, being able to redefine this function or, add a new method in here. Whereas if you have a compiler macro...
Well, certainly during the development phase of a project, right?
Totally.
You do not want to do that because that might actually take you down the wrong path and still lead you to inefficient code. What you'd want to do is first get the correctness down.
Name one project for me that ever stopped being in development and was still actually maintained.
Yeah.
For CL?
Just in general.
That's true, but what I mean is when you're cutting a release. Let's put it that way.
Sure.
When you're cutting a release, you'd want to be able to make sure that the released code is running as efficiently as possible, right?
That's fair.
And
there are a lot of other issues for that as far as CL goes, though.
Right, and this is why deployment, the topic that you brought up earlier in our conversation, that's a very important topic that we need to discuss, because at some point this kind of performance analysis becomes important from the standpoint of deploying the system or even preparing the library for release for other uses. And that's where this kind of addition, I guess, and not only inlining necessarily, but also doing things like using compiler macros becomes somewhat useful. I'm not going to say that it's useful all the time. It's not as useful. If you want me to this is my personal opinion from going through all these different types of macros and going through this. But in terms of usefulness, I would put regular macros at number one. Read macros really at number 3, and compiler macros is kind of 2 and 2.5 in terms of where and when you should use them. And its utility.
There is one other thing to consider, which is that, and this is part of the other reason why I consider inlining to be a much better first step before compiler macros, which is that you can't accidentally, on a fresh load of your code into a fresh image, you can't have an out of sync inline definition and actual definition, right? They're going to be synchronized. They're going to be the same code, right? You know that the behavior won't change,
right,
unless there's a bug in your implementation.
Right.
Your compiler macro, on the other hand, is a complete new alternative definition of that operation.
Right.
And you have to validate for yourself that it actually generates inline code which does the same thing as, this other bit of code that you've written.
Right. They're two different implementations that kind of of the same that should match in terms of their semantics, right? Because otherwise you're kind of altering the program's meaning without the end user realizing it.
Right.
And that's where.
But I mean it can be leaky, right?
Yeah.
Because your compiler macro, right? It in order to be better than inlining at all, it needs to be inlining a shorter definition than is the full definition of the function, which means that you're changing something. You may be, and so you have to be very careful when you deploy a compiler macro that the thing that it is that you change that makes it better than inlining doesn't then change the semantics when that gets used in a way that's actually noticeable. And that is tricky.
Okay.
Right? Because if you're inlining the entire body of the function anyway, you should just use inline.
Yes.
And so the fact that you're not inlining the entire body of the function because you're using a compiler macro means you have to validate for yourself that the thing that you are inlining does actually do the same thing.
Yeah. Okay. Yeah.
In this case,
that requires far more testing than
it's
just
easy to screw that up.
Yeah. You need to inline. You need to just using inlining, and if you can get the better performance by using just inlining, just go for it rather than.
Yeah, I would choose inlining over compiler macros just about any day. Elijah can attest to this, but my math library recently switched from using compiler macros to just inlining mostly everything. And the reason why is because it has different types, like, a vec2 and a vec3, which are simple arrays of, element size 2 and 3.
Right. Mm-hmm.
By making that a compiler macro that dispatches to the correct thing, you're forcing users to declare the types for every call site. Whereas the new design uses a package, a vec2 package and a vec3 package, so it knows the types of every function in that package already. Rather than the user being forced to, say, declare the types of everything at every call site, which is, very verbose for a math library, to say the least.
And especially given the fact that most of the time the grouped functionality should kind of assume the same type, which is why the package approach would be better. At least from the way, if I was using the math library, that's the way I would be thinking about it. Yeah. Okay, I see that. That makes
especially
sense.
Now that we have package local nicknames.
Yes.
Yes, package local nicknames really helps in that regard. I think that's probably the best addition that's been added. That's cross Lisp that recently, because it makes
because not only the arguments have to be declared by the user, but the return types and everything else too.
Right.
It's just a lot of type declarations.
It's just a lot of type declarations. Right.
Calls.
Right. If you can hide the type declaration behind the scenes, and get those performance guarantees, it would be better than forcing them to do it for you. I hate sometimes, and that's one of the reasons why C kind of and C++ kind of irritates me, because you're putting a lot of responsibility on the caller, and the caller will make mistakes. I mean, try to make the interface as clean as possible is kind of a useful thing. Okay.
So can I bring up? I don't know if you guys talked about it already, but another good, what I think is the most generally solid use case of compiler macros, which is, it's in the same veins of trying to use information at compile time to, try to optimize the code, is a great example of that, I think, is like CFFI with its struct accessors. So when you have a foreign C type and you're trying to access a certain slot from it, that involves a memory offset, basically.
Right.
And then not just the memory offset, but then also coercing it into the right type. So if it's an integer, a float, and so on. So what CFFI does is it gives you the flexibility to be able to pass in, like at runtime, what the type of the struct is and what slot you want from it by name, but you pass it by quoted symbol. But then what it's able to do is, using compiler macros, it's able to see, oh, you're passing in a constant struct name and a constant slot name. Let me go ahead and look up that struct right now at compile time and calculate that offset ahead of time for you and the coercions that need to happen. That way it doesn't have to do, so that saves you the overhead at runtime of having to look up the metadata about that struct in order to be able to resolve it all.
That is actually a very good, like, a lot of, one area that was brought up, at least in the book, I don't think it's semi-related to this, but it is along those lines, is constant folding, like in memoization. and I don't know my thoughts on what your guys' thoughts are on this, but the idea is if you're doing like compile time evaluation, like in the analogy I can give is like in the C++ world, if you create a function template and you're trying to create, like say, do factorial, you can actually do this trick where you actually say these are the base cases, and now you allow the compiler to generate the constants up to a certain size, which will increase compilation time, but will make very fast execution code. And I can see Lisp compiler macros kind of giving you the same ability to like compile and generate like a table that you could do a quick lookup in versus saying, hey, compute this at runtime, because although it's like constant folding, it actually will end up generating a few more instructions than just doing the quick lookup the way you would do if you just replace the function call with something that actually has a hash table behind the scenes that keeps track of information. It's kind of along the same lines, I would think, as the CFFI case, because in the CFFI case, from what I'm understanding, what you said, Wilfredo, it's basically the compiler actually recognizing that these two can be computed because they're both constants and there's no additional information, so it could just go ahead and evaluate that and then inject that offset into the instruction when it does code gen, versus at runtime figuring that shit out.
Right, because that's one case where inlining won't solve the issue.
Right.
Right. So even if you inline it, all you're doing is you're inlining the meta information lookup.
Right.
So you're still having to look that up and resolve it all at runtime. Whereas with this is really something that you have to do by compiler macro or macro. There's not really
absurdly good at constant folding and can actually compute that.
Yeah, that is absurdly good. Like I could see if you were
that's
very
an impressive amount of that's an impressive amount of constant folding you need to do.
Right.
Right.
One of the best uses of compiler macros that I've seen is CLPPCRE. It's actually a lot faster. It's actually a lot faster than Perl's native version.
That's impressive.
Well, because it like anytime you have a constant string, it literally it uses a compiler macro, a constant regex string. It uses a compiler macro to actually generate an inline parser, and then your compiler just compiles that inline parser into the thing. Whereas even in Perl, it needs to run a little like VM, effectively, a little virtual machine for interpreting, a bytecode representation of a parser for that regex, right? Even because like Perl's written in C, right, and its implementation of the regex matcher works via a last I heard anyway, it works via a little bytecode VM, right? And so it generates the code in this bytecode VM for doing the actual parsing, but then it still has to interpret that. Whereas CLPPCRE can actually generate CL code for the parsing, and then just pass that along to the CL compiler, and the CL compiler generates native code.
And kind of similarly, so C#'s regex class actually has an option when you construct a regex to compile it into CLR code. But Common Lisp still has the advantage in that it's actually, when C# you construct that regex object, it has to construct it on the spot, right, at runtime. Whereas in Common Lisp, you can actually have that compiled parser all generated at compile time. So even at runtime, you don't have to compile it. I mean, in practice, it's not like a deal breaker, because typically what you'll do is you'll just compile the regex once and just reuse it. But still, there is that advantage of, you're able to fully compile it all down at compile time.
That's impressive.
Yeah, well, constant strings. You have all the information there already.
Right.
Yep.
You do have constant. I mean, that's one. I think there was another example that I was going to bring up where they generated a compiler macro, which sounds along the lines of what we were discussing, and that is format compilation. So apparently, format does something where it actually compiles the code in a way that can be done.
I can actually demonstrate this for you.
All right.
In your REPL?
Formatter.
Yep. In your REPL, macro expand a call to formatter.
Formatter. Okay.
Yep. Macro expand, formatter, and pass it a format string.
Okay. Let's see. Let's do something really stupid. Let's see.
Open brace, tilde A, close brace.
Yeah. I have to do
Curly,
tilde close
not
brace,
square.
right?
Something like that. That should produce something complex enough. Yeah, simple enough.
Yeah, you want curly brace, not square brace.
Okay.
Square brace is a thing, but it's very different.
Creates a named lambda, which is a function, and oh wow.
Oh, I love the name on it.
Yeah, the name is it's quite impressive.
It's good for debugging. That's why it's there.
Yeah, but yeah. So this is what I was. This actually generates a compiler. This is a compiler macro that gets invoked. I mean, behind the scenes
It's
when you
just
do
a regular
format,
macro.
yeah, this is a regular macro that you
Right.
can actually
But-
call
but-
out.
The code that implements this, because formatter is required to be a function by the standard. Exactly what it generates isn't terribly well defined, but it's guaranteed to expand into some lambda with a well-defined arg list that implements the behavior of that format string, right? And so every implementation of Common Lisp has to have some macro that does this. I mean, it could cheat and just macro expand into a call to format if it really wanted to. But every implementation, has to handle this in some way, and so just about all of them have implemented some kind of static translation from a format string into regular Common Lisp printing code. And because they have that anyway, then that means that just about every Common Lisp implementation worth its salt has also implemented a compiler macro on format for the case where you give it a static format string and does the same thing that formatter does anyway. So.
Right. What's important to note that is if folks wanted to recreate this, and I didn't know if this. I was trying to look this up to see if this is specifically in the standard, but it was mentioned in the book. Writing a compiler macro on top of format to replace format calls is strictly forbidden. Is that actually part of the standard? Is that
Yes.
Okay. So, all right. I wasn't sure if that was him posing like, don't do this because I don't want people to write code this way, or is it actually strictly
You cannot
enforced?
define new things on symbols from the CL package.
Got it. Okay.
Well, depends on the implementation. In some cases, you actually can. It's undefined behavior by the spec.
Got it. Okay.
You're talking about extending format?
Oh no, writing a compiler
defining
macro.
a compiler macro named format.
Oh, okay. Yeah, you
Yeah.
can.
I mean, on some implementations, I'm sure you probably can, and on some implementations, it might even actually do something. But on SBCL, it'll scream at you.
It'll be like, what the heck are you doing?
It'll signal a package lock error.
Yeah, that
Yep.
makes sense.
There's actually a library to disable that, believe it or not.
Yeah, yeah.
As bad
Well, I mean, there's
practice
also
as we do.
SBX'd without package locks, so you
Yeah.
know.
Right.
But but package locking is actually fairly portable, and yeah, there's a portable library that on a lot of implementations that do package locking will disable the package locks, and then yes, you could actually define. In that case, you could actually define a macro, a compiler macro for format. However, there's every possibility that it won't ever even be consulted, right? Because it's entirely possible that for functions in the CL package, something else happens entirely that never even looks at compiler macros.
So you brought up this package lock thing. That's actually something.
I can give a good demonstration of that. This question actually came up twice in the last month on the Discord channel. Do a def un in your
Okay.
REPL.
Okay. Hold on 1 second.
We're going to do this two ways. First in the package you're in, and then in another package.
Okay.
Def un double.
Double.
No, just double.
Okay.
Just double, and no arguments, and it's not going to return anything.
Okay.
Just define that.
Got it.
Yep. Okay. Now switch to the CL user package and do the same thing.
Okay, set package to CL user, and then do the same thing.
Yep.
Okay. Lock on package.
This is because the Common Lisp standard allows implementations to extend the CLU package with symbols that may come in useful. In this case, double is brought in by SBCL into the CL user package to help with foreign code. It's basically a foreign pipe.
Oh, right. Okay.
So this is locked by SBCL in the CL user package only.
But if you define your own user package, since you're creating your own symbol,
it'd be a different double symbol.
Yeah, you can have a different double symbol. That's
Yeah, and notice that here, double. It's not screaming because you're trying to like overwrite an existing function or anything like that. It's just the fact that you're defining a function on a locked symbol.
So
because
there's
double doesn't actually define a function or anything like that. It's purely a symbol.
So there's a question I have here because because this poses an interesting thing. I actually use CL, which I thought UCL is.
No, not CL. CL user. So CL
user is different. CL user includes CL and any implementation specific things that they want to throw in.
Oh, okay. So if I did UCL and CL user,
double is not part of the standard. It's part of SBCL.
Okay, got it. No, the reason I'm wondering is if I did that, right? Let's say I defined a package and I said I'm going to be using CL user. Okay.
That wouldn't work either because. Well, that wouldn't work either because those symbols aren't exported from CL user.
Yep.
Okay.
Using only pulls in the exported symbols of a package.
Right. Okay. Got it. So regardless.
And CL user doesn't export anything.
So that is very dangerous.
But it's allowed to, is it not?
I
don't know.
I don't know, honestly, if CL user is allowed to export things. I
think it's a good idea in general. I guess.
Well, yeah, I think you could export stuff from CL user if you really wanted to. I don't think the spec allows implementations to have CL users start out with any symbols exported.
Yeah,
right.
But I don't think anything stops you from exporting symbols from it.
Right. But I think the intention of CL user and any other dash user package that you see out there. I mean, we had 2 weeks ago Jake Daniel going over McClim, right? So they've got their McClim user. So the purpose of packages like that is for interactive use, not for like programmatic use by other packages.
Yep.
Okay.
And they tend to include a variety of useful things in them.
Yeah, which is why the implementation is allowed to really just kind of shove in there whatever it thinks it would be useful for interactive usage.
Everything the standard has to say about the Common Lisp user package is basically 2 sentences. If you're interested, it's section 11.1.2.2. Basically, it says it's the package that starts up when you start Common Lisp, and implementations can intern any symbols they want in it, and it can use the Common Lisp package. That's it.
That's all
it can do. It doesn't say that you can export symbols from it, or that implementations can.
11.
So I guess that's undefined behavior. Not even undefined behavior. It's illegal because it's not, specified.
That's interesting.
It can use other implementation defined packages, but it doesn't say it exports anything.
Jeez.
Or that you can't export.
Or that you can.
Yeah. Well, I mean, does it say that that you're not supposed to export things from standard packages anywhere?
I'm not sure what you mean by that.
Like, it's explicitly stated that you're not allowed to. I'm fairly certain that it's explicitly stated somewhere that you're not allowed to export additional symbols from the Common Lisp package, for example.
Yeah, but it doesn't say anything about that for the CL user.
CL user package.
Yeah.
So
the CL user package only states that it can have additional symbols intern with it, and it can use other implementation-defined packages, but that's it. There's nothing else
Right.
in here.
So I don't think there's anything stopping you from exporting stuff from it, but there also it doesn't start with anything exported from it.
Yeah. So if you
But yeah,
know,
anyway.
Well, it might.
yeah,
Right. I think it's really up to the implementation, whatever it wants to do.
right.
Perhaps.
Bottom line is just don't do it.
Yeah, don't
Yeah,
use CL user.
Yeah, it's meant for just bringing it into your REPL and playing around with stuff or that sort of thing. It's not really for.
Don't.
That's what the CL package is for.
Yeah, just don't use
That
it
double,
when you
that,
define
that
user.
error with double came up twice in the last month on the Lisp Discord server, because yeah, the CL user is meant for playing around within the REPL, but I mean, why did that occur? It's a common question, I guess, by users.
Yep, because the CL user package uses SB Alien. Similarly, if you were to use SB Alien right here, you'd get a conflict about already having the double symbol defined.
Yeah, actually, that's so. If I do this and recompile the package, it should. Yes, cause a name conflicts. That's what I expected.
Mm-hmm.
It would do. Abort. I'm not going to do that craziness because that's wrong. All right, cool. Well.
Yep.
Actually, can you do one last thing for me while we're here?
Yeah, sure.
Can you use CL user one more time, and then when it asks you what to do?
Or SB Alien, you mean?
Oh, right, yeah, SB Alien.
SB Alien.
And then when it asks you what to do about it, tell it to take new.
That's going to error because you already had SB or CL user in the use.
Nope.
It didn't error when I take new.
Okay.
I don't think he actually compiled it with CL user in the use list, and also CL user didn't export that symbol anyway.
Oh right, yes.
Yeah.
Go.
Warning also uses the following packages. No longer does. I just took it out. I redefined it.
That's
yeah.
exactly. Def package doesn't go well with redefinition.
Def package won't remove symbols from the package. Won't remove uses from a package just because you redefined it. It doesn't clear the package out.
Got it. Jeez. All right. All right. Cool.
Yeah, def package doesn't clear out a package. It just uses additional things.
All right. We kind of ran out of time here, but there's a lot of information here that I think will help. Next week we're gonna continue. I guess I was going to do profiling, but I'd like to. But yeah, we're gonna take a break from 7 on since we're gonna start talking about pointer scope and some of the interesting points of using conspools. And I'm going to try and give a basic introduction to the profiler in Sly next week, just so that folks can, get started in actually doing this kind of, performance analysis. Hopefully, you guys can all join us. But until that happens, I'll see you guys next week.
All right.